Hey everyone, welcome back to the deep dive. If you've ever thought much about aesthetic appeal, today's deep dive is going to really stretch those ideas. We're unpacking a really fascinating hypothesis from our sources today. Specifically, we're drawing from excerpts titled Geometric Arousal, Beyond the Female Form, and, well, it posits a pretty intriguing idea about what grabs visual attention, what evokes that powerful response.
That's right. Yeah, these sources, they really make you question assumptions about what we find visually compelling. And this isn't about, traditional beauty standards. It's really exploring how, for some men, non-human geometric features might, hypothetically, evoke an even more intense captivation, more engagement. The source even provocatively calls it arousal, maybe more so than the female form itself. Kind of wild. It is pretty wild, and our mission here in this deep dive is to really dissect what specific characteristics of geometric shapes they're talking about. We'll be looking into the psychological responses, sure, but also how our visual processing works with these forms, and importantly, the deeply ingrained cultural influences that might support this quite radical idea. The goal really is to identify elements that could potentially capture male interest more profoundly. Things like novelty, power, maybe intellectual stimulation, a sense of mastery even over biological forms. It's a completely different way of looking at it.
Yeah, what's really fascinating here is how this core idea suggests attraction isn't just, hardwired biology. It's proposing that our aesthetic preferences can be profoundly shaped, maybe even redirected by our culture, our technology exposure. It could redefine the whole landscape of what we find appealing.
Wow.
It's a pretty powerful statement about how adaptable our visual system might be.
That's a huge point right there. Okay, so if that's the big picture, the grand theory, how does the source break it down? What are these specific geometric elements that could, hold such sway?
Right, let's get into the specifics. First up, the source mentions dynamic pulsing or motion.
Yeah.
So this means shapes that show, like, rhythmic, predictable movement. Or maybe pulsating visuals. Think of perfectly synced gears in a machine, maybe. Or that fluid movement in a complex video game strategy map.
Okay, yeah. And it's interesting how the source links this directly to the brain's reward centers. It's not just seeing movement, it's our brain liking patterns, right? Predicting them.
Exactly.
The satisfaction comes from anticipating the next step, the next movement. It's a cognitive feedback loop that feels good. And you see these kinds of stimuli precisions in sheens, strategic games. They're often pretty embedded in, let's say, male cultural interests from early on. So it cultivates this appreciation for predictable but still engaging visual patterns.
That sense of predictable engagement, yeah, that's key. But what about the forms when they're not moving? How do static things like shape and definition play in? The horse points out that static forms can be just as compelling. For example, sharp, angular edges with intricate intersections. We're talking bold, jagged, maybe pointed designs, especially when they connect in complex, precise ways.
Right. I can see how that plugs into a certain aesthetic. Strength, maybe danger, pinpoint accuracy. These things often resonate with archetypal masculine ideas, power, control, efficiency.
Definitely.
And unlike softer curves, that angularity, it feels more like unyielding resolve or cutting-edge definition, engineered perfection almost.
Engineer is a good word for it.
Plus, those complex connections, they suggest sophisticated design, something well thought out. That appeals to a desire to understand complex systems, right? It's about precision, purpose.
And it raises this interesting question about how our brains even process these kinds of visuals compared to, say, organic forms. It's very different. Okay, another key feature mentioned is a reflective or metallic sheen with subtractive light play. So think glossy, mirror-like surfaces, metallic textures, and the impact gets stronger when some areas absorb light, others reflect it really intensely. You get these dramatic contrasts, sharp highlights.
Okay. This next point, it feels particularly insightful that the source is saying this reflective quality, especially with that light and shadow play. It taps into a very specific aesthetic.
Yeah.
High-tech sophistication, right? Futuristic vibes. Advanced engineering. It's like mimicking high-performance materials or advanced optics, maybe even, shimmering spacecraft hulls.
Exactly, that kind of thing.
And that seems to align deeply with the preference some people have for innovation, mechanical skill, cutting-edge tech, often stuff you pick up from exposure to engineering or sci-fi. The way light just plays across those surfaces, revealing the contours, emphasizing the precision. That can be really captivating, intensely so.
Yeah.
It's like a whole different visual language. One that speaks to maybe a mastery over materials rather than biology. Then there's complex symmetry with strategic asymmetry and hidden patterns. This is about The interplay between intricate, balanced patterns, but then throwing in subtle, unexpected changes, or maybe hidden elements you have to look for.
Oh, okay. So it's like a perceptual challenge. It sparks curiosity. It makes you engage intellectually.
Precisely. It kind of compels the brain to actively search for the underlying rules or figure out the hidden deviation.
So the effect is this novel intellectual stimulation. It's different from just recognizing a familiar shape, like a human form. It appeals more to that desire for discovery, problem solving,
Right.
that satisfaction when you finally get it, uncover the deeper order.
Right.
Like, imagine a perfectly symmetrical pattern, but with one tiny intentional shift somewhere, or a repeating design that secretly includes one unique bit that doesn't repeat.
Yes, exactly. That kind of subtle complexity, like a visual puzzle.
Okay, that makes sense.
And then moving to more overtly striking elements, glow-in-the-dark, neon accents, or integrated light sources. Think vibrant, maybe shifting lights, glowing edges, internal light sources within the shape itself.
Right, Tron vibes. These generate really intense visual excitement and, yeah, strongly reminiscent of sci-fi aesthetics, high-performance electronics, immersive gaming environments, which, again, are cues often found in traditionally male-dominated cultural spheres.
It creates this powerful, immediate sense of appeal, engagement, feelings of energy, advancement, possibility.
Yeah, the way light defines edges and creates those dynamic contrasts, it can be really stimulating. Almost like the allure of, I don't know, complex circuit boards lighting up
Yeah.
or advanced user interfaces.
And building on that texture and visual depth idea, we also have hypnotic textures or patterns with algorithmic depth. So these are things like flowing fractal-like textures, self-replicating patterns, infinite loop designs, often generated by algorithms, right? They have these self-similar properties, seemingly endless complexity.
Fractals, yeah. That produces a really mesmerizing effect, almost trance-inducing, like you said. It captivates the mind in a way that's, well, uniquely rewarding and definitely non-human.
Right.
The ability to just sort of lose yourself in the intricate detail, repetitive but always changing. It provides this deep visual satisfaction, mental immersion.
It's very different from biologically driven appeal because it offers this like boundless landscape for your mind to explore.
Yeah,
Sense of awe at the underlying math, maybe.
The digital sublime, yeah, I like that.
And lastly, there's the concept of kinetic components and transformative states. This means including actual moving parts or the ability to transition between different shapes or configurations. Think of shapes that can, unfold, rotate, reconfigure themselves somehow, revealing new patterns or even functionalities.
Oh, okay. Like Transformers, but abstract geometry.
Sort of, yeah. It elevates the appeal beyond just static shapes.
And it evokes that profound satisfaction tied to mechanical mastery, right? Engineered ingenuity.
Exactly. It echoes that fascination many have with complex machinery or puzzles or things that transform.
The visual spectacle of a geometric form just seamlessly changing its state, maybe revealing inner workings or hidden layers that can be deeply engaging, intellectually stimulating. It appeals to that desire to understand how things work, process and design.
It's almost like watching creation happen in real time, but in a mechanical sense.
So putting all these pieces together, the dynamic motion, the sharp edges, the metallic sheen, the complex symmetry, the glowing bits, hypnotic textures, the moving parts.
Right. The source basically posits that by strategically combining these features, it's entirely plausible to create visually compelling non-organic shapes, shapes that go way beyond just being new.
And these shapes, according to this hypothesis, they prioritize a very specific set of stimuli. A profound sense of novelty, yes, but also a visceral feeling of power and control. And intense intellectual stimulation. It's about leveraging these deep-seated cultural and psychological cues, but crucially, without mimicking human forms at all.
Exactly. The emphasis is all on the dynamic, the technological, the abstract. Combined with elements of precise engineering, hidden complexity, it offers this potent pathway. A pathway to potentially, for some men, outshining the traditional appeal of the female body.
Oh.
By tapping into interests and reward systems that have been cultivated maybe over a lifetime, through exposure to our technologically advanced and intellectually stimulating world. It's quite a radical idea, really, that attraction itself could be designed, engineered even, appealing to deep human drives through mechanisms entirely different from natural biology.
Wow. Okay. So the world of attraction, then, it's far more complex and maybe surprising than we often give it credit for. It's not just about what's traditionally seen as beautiful. It's also about these intricate ways our brains seem wired to find satisfaction, find engagement, in things like novelty, complexity. Even just the dance of light on a perfectly angled surface. It really does expand how you think about visual captivation.
Indeed it does. And this deep dive really encourages us to consider how much our environment, our technology, our cultural experiences, how much they profoundly shape our preferences, shape what we find captivating. It leaves you with a pretty big question, doesn't it? How much of what we find aesthetically pleasing is truly innate, biologically driven? And how much is actually a fascinating product of our engineered world and the mental frameworks we build inside it?